day 3 or the third part. We're doing all the transformations. So before we do all the transformations, let's review the two equations. We've got the absolute value function. I'm going to do some color coding, which should at this point come as no surprise. Alright, so we're going to do function. Generalized equation. Alright, and I'm going to make a little table. So we're going to do quadratic. And remember, the parent is y equals x squared. And the absolute value function and that is y equals the absolute value of x for the parent. Alright, let's go a little further. So the generalized equation is very similar for both. Y equals, or f of x equals, a. Let's do negative a to have everything. So negative a parentheses negative b parentheses x minus h close your parentheses, squared plus k. Similarly, over here we have f of x, or let's call it g of x because it's a different function, equals negative a times the absolute value of negative b times x minus h, close your parentheses, close your absolute value, plus k. So I color-coded this a little bit different than last time. I want you to kind of take a mental note, or well, physical note, I guess. Everything I did in blue affects vertical values, and everything in red affects horizontal. So it works both, very similar for both. So this negative means reflect over the x-axis. A is a vertical dilation. And K translates vertically. All of these things happen just as is. So if this is plus k, we go up. If it's minus k, we go down. If this is 2, we dilate, we multiply everything by 2. If it's 1/2, we multiply everything by 1/2. And then reflection just makes it all negative. Inside the parentheses, though, is a little bit different. Reflections are the same, although it doesn't really matter for these because they're quadratic and absolute value, and since they're symmetric, a reflection over the y-axis looks the same. We can still write it. So the negative is reflect over the y-axis. H, oops, I forgot B. B is a horizontal dilation. And H is a horizontal translation. So just like how this, if it's minus h, it goes right, this is going to be the opposite of what you would think. So alright, example 1. We're going to graph y equals negative parentheses x minus 3 over 2 squared plus 1. And the first thing we're going to do is list the transformations in words. So first of all, we have this negative on the outside. This negative is going to be a reflection over the x-axis. Okay, and then dilation. So we have a horizontal dilation, and then it's the opposite. So because it says divide by 2, that means we have a horizontal dilation by 2. Then we have 2 translations, so we're going to translate right 3 and up 1. So what we've been doing in class is making a table, the parent values. So the parent is y equals x squared so my key points are negative 2, negative 1. 0, 1, and 2. So this will be 4, 1, negative 1 squared is 1, 0 squared is 0, 1, 2 squared is 4. Now what we do is we take these, we kind of ignore the equation and focus on the transformations, and we're going to extend our table. So a reflection over the x-axis, that is going to make our y values negative, right? So if everything was up above the axis, it gets reflected, it's now negative. So this is negative y. A horizontal dilation by 2 is going to take our x values and multiply them by 2. Translation, right 3 is going to mean plus 3, and translating up 1 will be plus 1. So negative 2 times 2 plus 3, negative 1 times 2 plus 3, 0 times 2 plus 3, 1 times 2 plus 3, 2 times 2 plus 3, and then we substitute in our y values, so negative 4 plus 1, negative 1 plus 1, negative 0 plus 1, alright, so now we can make our coordinate plane. So our y values are going to go up not very far at all, just a positive 1, so I'm going to go up to 2. I always like to go 1 higher. And then down to -3, so I'm going to go -4. X values, we do have one at -1, so I'm going to go to -2. And then +7, yeah. So I'm going to go over 8. And where's my straight edge? There it is. Oops. Okay, plot our points. So -1, -3, 1, 0, 3, 1, 5, 0, 7, -3. Turns into a parabola. And don't forget your arrows. And that is the end of that example. So let's do one more example. Graph y equals 3 times 2 times x plus 1 times, or close your absolute value, minus 2. So a few more transformations now. We have a vertical dilation by 3. Make sure you fully write out vertical dilation. I don't want to see VD. A horizontal dilation by 1/2, because remember it's the opposite, so if this is 2, that's by 1/2, and then translate left 1 down 2. Okay, I'm going to make my table real quick. So my key points, -2, -1, 0, 1, and 2, applied to the parent y equals the absolute value of x. We'll just make all of these originals positive. Then extending my table. So vertical dilation by 3 will be 3y, and we're going down 2, so it's minus 2. And then a horizontal dilation by 1/2 will be 1/2 x. So this will be negative, oh, down 1, 2. No, left 1. Sorry about that. Almost lost it. Okay, so -2 times 1/2 minus 1. -1 times 1/2 minus 1. Now, I'm okay with you leaving this as a decimal. I think it makes it easier for you to graph. So if you want to leave that as a decimal, go ahead. 0 times 1/2 minus 1. Okay, and our y values substituting in. Okay, and now I'm going to graph it. And I'm going to pause and graph because it's going to cut me off of time. -1.51, -1, -2, -0.51, and 0, 4. So my graph will look like this. And we are all done.